Welcome to the 7th episode of Analytical Chemistry series. In this video, we plan to start to talk about a really important concept in analytical chemistry, or even let's say in chemistry. And that would be acids and bases. When you're watching this video, perhaps you have some background knowledge about acids and bases, but trust me, this topic is really larger than you think. So we want to start this topic, we want to start this chapter. And when it comes to acids and bases, many different theories can be talked about. Many different definitions can be provided for acids and bases and how they work, how they react with each other. But in analytical chemistry, we only work with one or two of them. One or two of the theories are really common and we frequently use them. Others are also right, but we don't use them usually here. So let's start. The theory that we want to talk about is called Bronsted-Lowry. So Bronsted and Lowry were two really knowledgeable scientists in 1923, and they worked separately. It's really important, they weren't working together. They worked separately and proposed this theory for acids and bases, how they work, what are the definitions, and how they react with each other. So after that year, they called this theory Bronsted-Lowry because they proposed this theory at the same time. So what does this theory say? Actually, for base and acid, there are two definitions that complete each other. So because acids and bases are a little long to write, I'm going to show them with capital A for acid and capital B for base. Bronsted-Lowry says that acid is a substance, or acid is a species that can donate proton. So acid is proton donor. What about the base? I think you can guess the definition. So based on the first definition, base should be a proton, yes, a proton acceptor. So let's make it a little clearer. We can say that acid can donate proton. So I show the acid like this. It reacts and it gives H plus and A minus. So you may say, what is this? It's not a proton. Proton is just a positive charge. Yes, you're right. But take a look at the hydrogen atom a little closer. We can say the hydrogen atom is just one proton and one electron, which is running around this proton. So H plus means that only the proton remained and the electron is left. So in analytical chemistry, we show the proton using H plus. So HA gives H plus and A minus. So this would be the reaction for acids. However, for bases, we can have the reverse. B plus H plus, actually B should be minus. They can give BH. You can see that base accepted the proton, and at the end we have BH, which is a new species. So let's have it here. I'm going to provide some examples to make it more clear for you. So for the acid, I'm going to go with nitro acid, which is HNO2. And we pour some acid in some water, so it reacts with water, H2O. And in the product side, we have NO2 minus, which is nitrate ion, and H3O plus. What is this one? You may wonder, huh? I'm going to explain. So let's find out. Here we say HNO2 or nitro acid is our acid. I'm going to show it with red color. And because water is reacting on the opposite side of the HNO2, or it's reacting with our acid, it's called a base. You may say, wow, water is not a base, it's neutral. Yes, I agree with you. But because it's reacting with acid, it acts as a base here. So we have acid and we have the base. Now, look here, the acid changes to nitrate ion, and the water changes to this one. So on the other side, we have two other species that can have the potential for being another acid or another base. So this one can have the potential for being a base, and the other one can have the potential for being an acid. And by the way, H3O is just H plus and H2O. They mix together and they form H3O plus, or in a better way, in an easier way, we can call it hydronium ion. So hydronium ion and nitrate ion are our products, and they can act as an acid or a base because they are the products of the reaction of another acid and another base. Now, because we want to refer to these species in an easier way, we have some name for them. So for this one, we say conjugate acid, and for this one, we say conjugate base. I'm going to write it for you. Maybe it's important. Conjugate base and conjugate acid. Actually, I'm sorry, it's G, conjugate. So conjugate acid and conjugate base. Now, if you take a closer look, we can say that the acid converts to its conjugate base and the base converts to its conjugate acid. Maybe it's a little hard for you to understand, but let's go to the next example. I hope it helps. So here we have the ammonia as a base. Again, we pour some ammonia in water. So here we have water molecule. They react with each other, and then we have ammonium ion and hydroxide ion. Okay, so let's get back to our concept that says ammonia is a base. Sorry, I'm going to show it with blue color. So ammonia is a base, and it converts to the ammonium ion. And this one has the potential for being an acid. So I call this conjugate acid. Then we have the H2O molecule, which is an acid here. Again, yes, you're right, H2O is neutral, but because it's reacting with ammonia, it acts as an acid. So water is an acid here, and as you can see, it converts to hydroxide ion, which I'm going to call it conjugate base. So taking a look at these equations and reactions, we can understand that a base can only accept a proton in a circumstance or in a situation that another acid exists. Or we can have the same, let's say, definition for the acid. So the acid can donate hydrogen plus, or I don't know, proton or anything. The acid can donate the proton in the circumstance or in the situation that another base exists. So we can say that the acid donates its proton to the base and the base accepts the proton. So they can't work separately. In one bottle, we can't have only the acid or only the base. Both of them exist and both of them react with each other, but the amount of acid or the amount of base is more than the other one. So at the end, we can say that a solution is acidic or basic. Now, I think it's enough. Let's have another concept to talk about. Now, consider a glass of water. Think you have one glass of water and it's partly poured. So some water is inside this glass, and you may think that the only species that exists in this glass of water is just the water molecule itself. But unfortunately, I have to say you're wrong, because we have a reaction which says a water molecule plus another water molecule can give us one hydronium ion plus one hydroxide ion. So I know it's not normal. You may think that one glass of water, nothing is affecting on that. Why is this happening? This is because of a characteristic of water itself, and it's called self-ionization. It means that when you have a glass of water and nothing else is added to this glass, the water itself ionizes into hydronium and hydroxide. But be careful that the amount of this reaction and the amount of these products are really neglectable. So if we say that moles of hydronium ion divided by moles of water molecules, we can strongly say that this is approximately 0 because it's really small, but there's something important to consider. We can say that the concentration of hydronium ion is exactly equal to the concentration of hydroxide ion, because both of these species have the same coefficient in this reaction, which is 1, and it means that 2 molecules of water give us exactly 1 molecule of hydronium and 1 molecule of hydroxide. So because the amount of hydroxide and hydronium ions are equal, we can say that a glass of water is totally neutral and it's not acidic or it's not basic. Thank you so much. I think it's enough for this week. I give you some time to work on these concepts. Try to write the reactions for other different bases and acids. I mean the famous ones that you know, like hydrochloric acid, hydrofluoric acid, or let's say sodium hydroxide. They are acids and bases, I mean famous or popular acids and bases. I give you some time. Try to work on these concepts. Try to write the reactions that are happening in water. I mean when you pour some acid and pour some base in the water. And next week, we are going to talk about some more complicated concepts in acids and bases. And hope to see you again in this channel. If you found this video useful, don't forget to subscribe and hit that like button. See you next time. This is Chem Explain.